In this video, we are going to discuss Python exception handling. We'll cover how to gracefully handle errors using the try, except, and finally blocks. Exceptions are events that occur during program execution that disrupt the normal flow of instructions. When Python encounters an error, it creates an exception object. Let's look at an example. Here we have a function named calculateAverage, which returns the sum of numbers divided by the length of numbers. Now, if we pass an empty list to this function, it will raise a zero division error because we are dividing by 0 as the length of the list is 0. Let's understand the basic try-except structure in Python. The code that might raise an exception is placed inside the try block. This is the normal execution path. If an exception occurs, the code inside the except block is executed. This is the alternative execution path. Here's a simple example. We try to convert the string ABC to an integer. This will raise a value error because ABC is not a valid integer. The except block catches this value error and prints invalid input. Python allows you to handle multiple exceptions using separate except blocks. This way, you can respond differently based on the type of exception that occurs. In this example, we take user input and try to convert it to an integer. If the user enters something that's not a number, a value error will be raised, and the first except block will handle it. If the user enters 0, a zero division error will be raised when we try to divide 100 by the number, and the second except block will handle it. The last except block without a specific exception type acts as a catch-all for any other exceptions that might occur. The finally block always executes, regardless of whether an exception occurred or not. It's useful for cleanup operations like closing files or releasing resources. In this example, we try to open a file named data.txt and read its content. If the file is not found, a file not found error will be raised, and the corresponding except block will execute. The finally block will always execute, printing cleaning up resources. It also checks if the file object exists and closes the file to free up resources. The else block in a try-except structure is used to execute code only if no exceptions were raised in the try block. In this example, we try to convert the user's input to an integer representing their age. If the input is not a valid integer, a value error is raised, and the except block prints that's not a valid age. If no exception occurs, the else block is executed, printing the user's age. The finally block, thank you, is always executed, regardless of whether an exception occurred or not. The else clause is executed after the try clause completes successfully, meaning when no exceptions are raised but before the finally clause. You can also raise exceptions manually using the raise keyword. This is useful for validating input parameters, signaling impossible conditions, and communicating specific error states. Here's an example of a function named setAge. If the age is not an integer, we raise a type error with the message age must be an integer. If the age is less than 0 or greater than 150, we raise a value error with the message age must be between 0 and 150. Otherwise, we return the age. Let's look at some best practices for exception handling in Python. First, be specific. Catch specific exceptions rather than using bare except clauses. This makes your code more readable and maintainable. Second, keep try blocks small. Put only the code that might raise exceptions in the try block. This makes it easier to identify what caused the exception. Third, use context managers. Use with statements for resource management instead of try finally blocks with manual close calls. Finally, document exceptions. Document which exceptions your functions might raise in docstrings. This helps users of your code understand how to properly handle potential errors. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.